Hey guys, so today's video was supposed to be about rusting and the conversation about the differences between rust and iron. And I changed my mind because I've had a few questions from a couple of different schools about condensation. So I'm going to review condensation. Now, I came out close to sunset because I don't want my glass to get too warm during the middle of the day. So I'm waiting until the end of the day when the sun is low in the sky. Still warm out, but it's starting to cool. And I've got this glass cup, this container, sitting right here on this column. And in a moment, I'm going to pull some ice out of my cooler and put ice into the glass container that's sitting out here in the open air. Now, there's water vapor in the atmosphere around us. I can feel that water vapor in the air as humidity. It's not very humid right now, but I can certainly feel the water vapor in the air. And you guys know what humidity is like. You're in Florida. You know what it's like to be humid. So in a moment, I'm going to add some ice to the cup. And what's going to happen, what we want to observe, is that right now the cup is the temperature of the air, plus it's being warmed a little bit by the sun. Now, when I put the ice inside the cup, then the cup itself, the glass, is going to start cooling, and the air around the cup is going to start to cool down. As that air around the cup cools, the water vapor in the air will condense, and we'll start to see some water droplets forming on the outside of this cup. So as you can see, there's a lot of water behind me over here. I'm down by Goodland, just off of Marco Island. There's a lot of open water behind me, so that water vapor in the air is water that has evaporated from the ocean water behind me. Reach in, fill that up with some ice. So I filled that cup with ice. I'm going to take that top one off. I don't want you to think that the ice is melting down the sides of the cup, because that's not what's happening. What's happening is that as the glass cools, the water vapor in the air next to that is cooling and will condense onto the sides of the cup. Now you can see that the ice inside the cup is already starting to melt. That glass is not cracked, it's not broken, there's no water that's going to leak through that. So the water that's inside is going to stay inside. We're looking for the water that forms on the outside, otherwise known as condensation. Notice that you can see the water inside the cup melting and dripping down to the bottom of the cup. The cup is starting to fill up with liquid water as the solid ice melts. Notice that as the sun's energy, the heat from the sun, is increasing the temperature of the glass and the solid ice, that ice is starting to go through a physical change in state. As the temperature increases, the ice starts to change into a liquid, and that process of changing from solid to liquid is melting. And that's the result of temperature increase in the ice. The source of that temperature increase, of course, is the sun. Now the same thing is happening in the ocean water over here behind us. There's a temperature increase happening in the water of the ocean, and as the temperature of that water starts to increase, it increases the process of evaporation, which is when liquid water changes into gas water vapor. Now that water vapor travels through the air, and we are causing condensation over here on the sides of the glass. As the temperature of the water vapor in the air cools, we're starting to see drops of water condensing on the side of the cup. There's a little bit of water on my fingertip. There's some rust from earlier. I was playing with rust earlier. So we're seeing evaporation, condensation, and melting all happening as the result of temperature increase caused by the sun. Later, when the sun goes down, the temperature of the air will decrease, the temperature of the plants and the wood and the rocks and everything else is going to decrease, which will cause the water vapor in the air, because of temperature decrease, to condense and form on those surfaces, which we call dew. That's where dew comes from. Those are those water drops that you see on those surfaces in the morning because they've had all night to condense. That process actually starts happening right after sunset. What I'm doing is an investigation. It's not an experiment. Now, what makes it different from an experiment is that I've got one setup. I'm doing one thing. I'm asking a question: how does condensation form? I don't have a control. I can't call this an experiment because I don't have a control. If I were to have another cup next to this filled with water but no ice, or a cup with nothing in it, and I was to test those two compared to each other, then this would be an experiment. But it's an investigation because I'm just asking the question. I'm not testing a hypothesis, and I don't have a control. I don't have a second group here that I'm controlling with just water or just air. So now the cup is filled with ice and water, and you can see if I take my finger and run it along the edge that I'm picking up water condensed on the outside of the cup. See if I lift it, if any of that water will drip down. Nope. I'll make sure I don't spill it. I don't want... Oh, but I can tell, look. I can tell that where it's been sitting is wet. The surface of that column has become wet due to the condensation dripping from the bottom of that cup. So that's how dew forms. Later on, when the sun goes down, these plants over here, this rock, this column, the air temperature around them is going to cool. As that air temperature cools, as that air temperature decreases, the water vapor in the air is going to condense onto the plants, onto the rocks, onto the wood columns, and form water droplets. That's how dew is formed.